Physics 151. So once again, I wish you were here in the lab, but today I think I'll do an experiment and save the data, and then you can take a look at it in your breakout rooms at home. So what I have is I have a motion sensor. What the motion sensor does is it sends out ultrasound signals, which then reflect off the environment. So I've got this cart, which can move along. If I click Start Detector and collect data, then as this goes away or closer, I get position versus time. I can stop it. I can also click on Analyze, and I can save the velocity versus time curve of this object. And I'm going to collide it against that bumper over there. So if I do that, press Collect. Let's start some new data. Analyze, I send it, and then stop. Then what I'm going to get is the position will be like a triangle. It'll go up and then down. And if I save the velocity, I've got a positive velocity, looks like about 50 centimeters per second, and then it switches to a negative velocity of about minus 40 meters per second after the collision. So that's the velocity part, and it's one of the graphs I'm going to save for you. The other part will be the impulse. And so what we've got on here, you kind of see it's called economy force sensor. It's a Pascal force sensor. And it has the ability to record the force that's pressed down. There's a tare button on it, which will get it back to 0. So if we take our force data, force sensor, and click Clear Data, Acquire Data, then I'm going to press tare actually to get to 0. If I push down, I got a big spike, and that's mounted onto the cart. So if I press Clear Data, Acquire Data, don't forget to press the tare button, and again I do this collision, stop it, and what I'll have here, zoom in on it a little bit, is it'll be 0, 0, 0, 0, 0, and then a great big impulse. And it goes up to about 13 newtons maximum, and then back down to 0. So during this collision, over a time from between 4.22 up to about 4.27, 4.21, 4.27. So that's 0.27 minus 0.21, so about 0.06 seconds. So 60 milliseconds is the amount of time it takes the force to go up to the maximum and then back down again. So that's sort of the bouncing time, or the collision time. So I'm going to do a few runs in which I actually run both of these at the same time, and I'll call each trial by a number. So let's do number 1 first. So how are we going to do it? I'm going to press. So it's a little hard to do it when there's just one of me, but if there was more of me in this room, we'd have to be wearing masks. I'm going to clear data. I think first thing I'm going to do is start the force sensor, press tare, and I'm going to press collect data, stop, and stop. Okay, so that's a run. And then what I'll do is I'll export that data. I'll call it force 1. Save it for you, force sensor data file. And then for this one, I'm going to click Analyze here, and I'm going to file velocity data set. Save that. I'm going to call that VT1 and save that as a text file. Okay, and so I'm going to do that 4 more times so that you have 5 sets of data, 5 collisions, and then you can analyze. And I think the idea here is you should be able to compare. Oh, one more thing I got to do. I should measure the mass of this thing right here. So the mass is 613.7 grams. So don't forget to write that. 613.8 grams actually. It's depending on how much I said. 613.8. Of course, the purpose here is to verify the impulse momentum theorem, which says that the impulse, which is the integral of the force times over the force versus time graph, is equal to the change in momentum. So, and also, I don't know if you noticed this, but as this thing is going along, I was trying to hold the wire. So this wire, which connects the force sensor to the DAC board over here, which then is connected to the computer, can exert an external force. So I was trying to kind of hold it steady to the side of it so that it did not exert any forward or backward force. So, and there's a little bit of friction in the wheels of these carts, but most of the force during the collision is coming from the force of this clamp onto this, which is going to be the external impulse. So the external impulse on the system, which is this 613.8 grams, is going to be hopefully equal to the change in momentum of the system, which we can measure since we know the velocity.